Good morning. Good morning. Today our new class is unbiased positive clippers and unbiased negative clippers. Unbiased positive clippers and unbiased negative clippers. Okay. Next, recap of this presentation. In previous class, we discussed about diode as a clipper, diode as a switch, clipper and different types of clippers. Diode as a switch, diode as a clipper and different types of clippers. So these three topics are completed in previous class. Okay. And next, objectives of this presentation. On completion of this period, you would be able to understand unbiased series diode positive clipper, unbiased shunt diode positive clipper, unbiased series diode negative clipper, unbiased shunt diode negative clipper and summary. Okay, so these topics are discussing one by one now today class. Okay, from these topics the first topic is unbiased positive clippers. So we know the unbiased positive clippers are divided in two categories: unbiased series diode positive clipper, unbiased shunt diode positive clipper. First of all, we discussed about unbiased series diode positive clipper. Okay, so see this is the figure of unbiased series diode positive clipper circuit diagram and also input and output waveforms of unbiased series diode positive clipper. Observe this figure. So here diode is connected in series with input and output. Okay, so first of all, unbiased series diode positive clipper. When the diode is connected in series with input and output without bias is called unbiased series diode positive clipper. Okay, what is the definition of unbiased series diode positive clipper? When the diode is connected in series with the input and output without bias is called unbiased series diode positive clipper. So this is the figure of unbiased series diode positive clipper as shown in figure. In this figure, observe this figure. Here one resistor is connected. The voltage drop across resistor is the output voltage. Here the voltage drop across the resistor is nothing but the output voltage. Okay, and next, so observe this input and output waveforms. We can apply the input waveform, that is the sine waveform at the circuit of input Vi. Okay, during positive half cycle of the input signal, so the diode is reverse biased. The diode is reverse biased. Reverse bias means it acts as an open switch. The diode is connected in reverse bias, then it acts as a open switch. Okay, here also observe this. During positive cycle of the input signal, the diode is reverse biased and the diode acts as an open switch. If diode acts as an open switch, there is no current flows through the resistor or so, and hence no voltage drop across the resistor. No voltage drop across the resistor. So then the result, the output voltage is 0. Then the result is the output voltage is 0. So that is the positive half cycle is clip off. The positive half cycle is clip off. Therefore the output voltage V0 is equal 0 volts. Okay, what about negative half cycle? During negative half cycle of the input signal, observe this input signal negative half cycle. During negative half cycle, input signal is Vin. So Vm is Vm plus Vm minus Vm is the peak to peak amplitude. Okay, so T is time in seconds. Okay, x-axis is taking on time and y-axis is taking on voltage. So either input voltage and also output voltage is taking on y-axis. Okay, observe this. Positive half cycle is clip off. Observe the output waveform. This output waveform, there is no forming of positive half cycle because there is no current flows through the circuit. That's why there is no voltage drop across the resistor. Then output voltage is 0. So therefore the positive half cycle is clip off. What about negative half cycle of the input signal? See this, during negative half cycle of the input signal, the diode is forward biased. Diode is forward biased means diode act as a closed switch. Diode act as a closed switch. Therefore, the current flows through the resistor R. The current flows through the resistor R. Hence, the total input voltage appears across the resistor R. Hence, the total input voltage appears across the resistor R. That is, the negative half cycle appears at the output. So, the negative half cycle appears at the output. That is, therefore, the output voltage V0 is equal input voltage Vi. Therefore, the output voltage V0 is equal input voltage Vi. Input voltage Vi. Okay. So, this is nothing but unbiased series diode positive clipper. Okay. So, what about unbiased shunt diode positive clipper? Shunt means it is nothing but parallel connection. Shunt means it is nothing but parallel connection. Okay. So, what about unbiased shunt diode positive clipper? Series diode and shunt diode both are two types of positive clippers also unbiased. Okay. Next, see this figure. This is the figure of figure A and figure B. This is the figure of unbiased shunt diode positive clipper circuit diagram and also input and output waveforms and also input and output waveform. So observe the what is the definition of unbiased shunt diode positive clipper? When the diode is connected in shunt, when the diode is connected in shunt with the input and output without bias is called unbiased shunt diode positive clipper. When the diode is connected in shunt with the input and output without bias is called unbiased shunt diode positive clipper as shown in this figure. Okay, see this figure. See this figure during positive half cycle of the input signal. See this figure during positive half cycle of the input signal. So here the diode is forward biased. Forward bias means positive. That means the anode of diode is connected to the positive terminal of input voltage and cathode of diode is connected to the negative terminal of input voltage. These connections, that means positive is connected to positive and negative is connected to negative. This connection is called as forward bias connection. What about reverse bias connection? Opposite polarities are connected is nothing but reverse bias connection. That means positive is connected to negative and negative is connected to positive. That means cathode of diode is connected to positive terminal. Cathode means negative. Anode of diode, anode means positive. Anode of diode is connected to negative terminal. That's why the type of connection is nothing but reverse bias connection. See this figure. During positive half cycle of input signal, the diode is forward biased and act as a forward bias means it act as a closed switch and hence the current flows through the circuit. Hence it is nothing but short circuit the output. That means the output signal voltage is 0. The output signal voltage is 0. That is positive half cycle is clip off. Positive half cycle is clip off because we can apply, see this figure, we can apply the input voltage that goes to the diode. In this case diode is forward bias, it act as a closed switch, it act as a short circuit the output. Then output goes to resistor. Resistor is nothing but it can drop some voltage. The dropping voltage is forwarded to diode. It goes to input. Okay, there is no output voltage. That's why here output is 0. Therefore, the positive half cycle is clip off. Positive half cycle is clipped off. Okay, observe the input and output waveforms. Output waveform, input waveform. Input waveform positive is formed. There is no output waveform. Okay. Next, in this case, during negative half cycle of the input signal, during negative half cycle of the input signal, so the diode is reverse biased. So diode reverse bias means it act as a open switch. It act as a open switch. Open switch means there is no current flows through the diode. There is no current flows through the diode and no voltage drop. Okay. So as a result, so input negative cycle appears across the output. That is, output voltage V0 is equal input voltage. Okay. I explain this. We can apply the input voltage at the input side of the circuit, so that goes to resistor. Resistor drops some voltage. Which type of voltage? Here in input voltage, total input voltage is given to the output. That's why, so output is equal input. Okay. As a result, the input negative cycle appears across the output. Okay. This is nothing but unbiased shunt diode positive clipper. This is nothing but unbiased shunt diode positive clipper. Okay. From this topic, unbiased series diode and unbiased shunt diode positive clippers are completed. Okay. And next then goes to observe this. So this is the during positive half cycle of input signal. This is the during, figure B is nothing but during negative half cycle of the input signal. Okay. So these two topics are completed. These two types of topics are completed. Thus, the positive clipper has clipped the positive half cycle completely and allows negative half cycle of the input signal. I repeat this point again. Thus, the positive clipper has clipped the positive half cycle completely and allows negative half cycle of the input signal. Okay. From this point, so these two topics are completed. And next one is unbiased negative clippers. Next one is unbiased negative clippers. Unbiased negative clippers again divided in two categories. So unbiased series diode negative clipper, unbiased shunt diode negative clippers. One by one discussing now. Okay. First of all, so we can discuss about unbiased series diode negative clipper. See this unbiased series diode negative clipper. So this is the circuit diagram and input and output waveforms of unbiased series diode negative clippers. Okay. So in this case, during positive half cycle of input signal, during positive half cycle of input signal, so observe this diode, anode is positive, cathode is negative. The diode is forward biased because positive is anode of diode is connected to positive terminal and cathode of diode is connected to negative terminal through resistor. Okay. So therefore, the diode is forward biased. So diode forward bias means it acts as a closed switch. Therefore, the current flows through the resistor or the voltage drop across it. Therefore, the output voltage is the total input voltage appears across the R. Therefore, mathematically it can be expressed as the output voltage is equal input voltage. Okay. I repeat this point again. During positive half cycle of input signal, the diode is forward biased. It acts as a closed switch. That means it is a short circuit. Therefore, the current flows through the resistor R and the voltage drop across it. Therefore, the output voltage is the total input voltage that appears across resistor R. That goes to output. Okay. Therefore, output voltage V0 is equal Vi. Therefore, output voltage V0 is equal Vi. Okay. So, observe these waveforms, input waveform and output waveform of positive half cycle only. So, output of positive half cycle appears across the load resistor. That's why output is appeared. Next, during negative half cycle of input voltage. During negative half cycle of input voltage, in case of negative half cycle, the diode is reverse biased. The diode is reverse biased and it acts as a open switch. That means it is an open circuit. There is no current flows through the resistor. Open circuit means there is no current flows through the resistor. Hence, no voltage drop across the resistor. That's why output is 0. There is no output forms. Okay, so as a result, the output voltage is 0. So therefore, in this case, so the negative half cycle is clipped off. In this case, the negative half cycle is clipped off. That is, the output voltage is equal 0 volts. Okay, this is nothing but the unbiased series diode negative clipper. Observe these figures, figure A and figure B. Figure A is nothing but during positive half cycle of unbiased series diode negative clipper. So what about figure B? Figure B is nothing but during negative half cycle. During negative half cycle of unbiased series diode negative clippers. Okay. And next, unbiased shunt diode negative clippers. Another type of unbiased negative clipper is nothing but unbiased shunt diode negative clipper. So observe this. When the diode is connected in shunt means it is nothing but parallel connection with input and output. So unbiased shunt diode negative clipper, when the diode is connected in shunt, with the input and output without bias, when the diode is connected in shunt with the input and output without bias is called unbiased shunt diode negative clipper. Unbiased shunt diode negative clipper. I repeat once again. When the diode is connected in shunt with the input and output without bias is called unbiased shunt diode negative clipper. Okay, observe these waveforms, input and output waveforms, and also circuit diagram. See this, during positive half cycle of the input signal, okay, so observe these figures. So figure A is during positive half cycle and figure B is during negative half cycle. Observe figure A. During positive half cycle of input signal, the diode is reverse biased. Reverse biased means it act as a diode act as a open switch. That means it is a open circuit. Therefore, the current flows through the resistor R. And hence voltage drop across it. Therefore, so this voltage drop goes to output voltage. Therefore, as a result, the output voltage is input voltage. Then the input waveform, the positive half cycle appears at the output. That's why output voltage V0 is equal Vi. Okay. And next, during negative half cycle of the input signal. In this case, the diode is forward biased. And diode act as a closed switch. It is nothing but a short circuit. Hence, the short circuit the output. That means output voltage is 0. Because the total voltage drop across the short circuit only. Okay. So there is no flow through the output. Through the output. Okay, that's why. So the negative half cycle is clipped off. Therefore, the output voltage is 0 in negative half cycle of input signal. Okay, so therefore output signal is clipped off. This is nothing but unbiased shunt diode negative clippers. From this topic, unbiased series diode negative clipper, unbiased shunt diode negative clipper are also completed. Okay. Total 4 topics: unbiased series diode positive clipper, unbiased shunt diode positive clipper, unbiased series diode negative clipper, unbiased shunt diode negative clipper. All topics are cleared. Okay. So very, very important topics. Don't confuse them. Okay. So prepare well. Okay, and next summary of this presentation we have seen. Next summary of this presentation we have seen: unbiased series diode positive clipper, unbiased shunt diode positive clipper, unbiased series diode negative clipper, unbiased shunt diode negative clippers. Okay, so is completed. And next, frequently asked questions may be asked. Frequently asked questions may be asked. The first question is: explain the operation of unbiased positive clippers with the help of circuit diagram and waveforms. In this question you can write both positive series diode and shunt diode operations also. Okay, so in this question may also be asked in different ways. So the first one is: explain the operation of unbiased series diode positive clipper with the help of circuit diagram and input and output waveforms. And in this question also another question may be asked: explain the operation of unbiased shunt diode positive clippers with the help of circuit diagram and also input and output waveforms. Okay, so otherwise another question may also be asked: draw the circuit diagram of unbiased positive series and shunt clippers and also input and output waveforms. Okay, so many questions may be asked in one topic also. Okay, so and next second question may also be asked in today topic: explain the operation of unbiased negative clippers. Explain the operation of unbiased negative clippers with the help of circuit diagram and waveforms. This question may also be split into different type of questions. The first question is: draw the circuit diagram and input and output waveforms of unbiased series and shunt diode clippers, negative clippers. Okay, and another question may also be asked from this question. So explain the operation of unbiased series diode negative clippers with the help of circuit diagram and waveforms. And another question may also be asked in this question: explain the operation of unbiased shunt diode negative clippers with the help of circuit diagram and waveforms. So different type of questions may be asked in today topics. So today topics are very important topics. Okay, so prepare well, don't confuse them. Okay, any doubts? Okay, thank you.